Hi everyone, I am Nikhil Mittal. Welcome to day one of week of continuous intrusion tools. Starting from today, 30th November 2015, I am starting a week-long series of blog posts and accompanying videos where we will have a look at continuous integration tools from an attacker's perspective. I often come across these continuous integration tools in enterprise environments during my penetration tests and red team engagements. What amazed me is that these tools have access to very sensitive data like uh, source code, credentials, a huge number of slaves, that is, access to a large number of machines, and much more. But still, when it comes to security of these tools, both the developers of these tools and users seems to not care about that. As we will see in this week, that these tools lack so many basic security controls which are normal for other enterprise tools. I also talked about this topic at Black Hat Europe and DeepSec a couple of weeks back. And the discussion there with users of these tools and security professionals again highlighted the lack of awareness around security of these tools. So I hope to draw everyone's attention towards the attack surface of these tools from this week of continuous intrusion. So let's get started with day one. In day one, we will have a look at Jenkins. So Jenkins is arguably the most widely used continuous integration tool. While there are so many public instances of Jenkins and they are very good for OS int, that sometimes from an external in an external penetration test, there may actually be no need to compromise a Jenkins admin, a Jenkins server. Only the build outputs, etc., divulge enough information for us as an attacker to do further attacks. So for that, I request you to look at the Google Docs portion of the accompanying blog post on my blog, labofapenetration-tester.com. Right now, what I would like to demonstrate here is how we can use Jenkins for gaining access to the underlying operating system or on the server where the Jenkins server is running. So all of these continuous integration tools we are going to have a look at, they provide ability to manually trigger builds, and when we have the ability to configure and trigger builds, we can use them to execute commands on the operating system level. So to get access to such a user, Jenkins, okay, prior to that, Jenkins by default has no authentication, and so what we are having a look at right now is a properly configured Jenkins server, which uses the recommended security controls as per the Jenkins documentation. So by default, Jenkins has no authentication. Everyone who knows the URL has admin privileges. It runs with the service Jenkins. On Windows machines, it runs with system privileges. On Linux machines, it runs with user Jenkins. Uh, Prior to version 1.5.80, anyone with anonymous privileges can list all the users and have a look at build outputs, which is the same case in our lab. But even for the latest versions, most of the enterprise, not most even, in fact, all of the enterprise instances I've seen, they almost all of them allow access to read access to anonymous. So this is a standard Jenkins setup. So to execute commands, we must have access to a user which has privileges to configure builds. Note that Jenkins allows distributed builds. That means there is a master machine. For example, here this is the master, and then there could be so many slaves. I've seen environments having more than 300 slaves, but generally 10, 20, 30 slaves are present. Also, uh, Jenkins has no protection against brute force attacks. That is, we can try login and any number of times. And also, there is no password policy, no password complexity, no password history, nothing. And a quick note that whatever we are going to discuss with Jenkins should apply on Hudson as well, because they share a similar code base. So let's get started. First of all, what we need to start our brute force attack is usernames. So on Jenkins, most of the Jenkins instances, if you click here, people, or go to this URL, should be able to see all the users, all the built-in users, and all the users who have logged in into Jenkins. So we can quickly, so there are just 3 users on this instance. We can quickly note these down. Now to brute force Jenkins, we must capture, we are going to use burp suits intruder, and therefore we must capture a login request. So let's just use something user pass and try to log in. So we got an error, and here we need to use this post request. Let's send it to intruder, and we can safely remove this JSON parameter, and we need not test parameters. Any other parameter, we are going to just use the username and password parameter. We're just going to test it. First of all, we'll use the pitchfork method. In my experience, because of the lack of password policies, many Jenkins users use their username as password as well. So let's just use a payload set. I have pre-prepared list of users and passwords. So I'm just going to, as a user list, I'm going to use these, and as a password list, I'm going to use this list. That is the same list with usernames and passwords. And also make sure that we tell intruder to follow redirects, because after a successful authentication, we'll see a redirect. Now let's just start the attack. As you can see that, although this is a lab environment, so I configured it this way, but as you can see that this is how success looks like. To make, we can always use, let's use actually a different word list so that it looks a bit better, and we'll use the cluster bomb in this case. So let's start it. As you can see that we have a success here, so we can pause the attack. So this was actually a quick demonstration to show you how we can brute force Jenkins using burp intruder. You can use any tool you want. So now we have credentials for this user. So let's just quickly log in using the config user and the same password. Now if you see that we do have configure permissions on this project, we are still not the administrators of Jenkins. With this ability to configure builds, we can actually do very interesting stuff. So as you can see that in this example I have here, I've added a build step which called execute Windows batch command, which allows us to execute, as the name says, Windows commands. So let's just copy this thing so that we need not create it later on. And now if I just run who am I here, save it and build it. So we have triggered a manual build. And if you see the console output of this build, you'll see that we have system privileges on the slave, which is very good. With system privileges, even if it is on a slave machine, we can do a lot of stuff. Not only that, if we are on a Windows machine or even if it is a Linux machine, using built-in tools, we can actually get a reverse connect shell from this Jenkins instance to do a lot more interesting stuff. I advocate using PowerShell for post-exploitation for this specific reason. If we know PowerShell, we can right now use this ability or abuse this ability to execute Windows batch command to do a lot more without having to use any, having to drop any executable or use anything else. We'll be strictly sticking to memory and do a lot of interesting stuff. For example, we can use a reverse shell here. For that, I'm going to use a reverse shell from a PowerShell toolkit called Nishang, which I maintain. So first I need to have, I think I have an instance of that in this current directory. So what you, if you're trying it with me, if you want to do it, you need to use this one, invoke PowerShell TCP one line. It contains two one-line shells. So use whatever you want. Just copy that one from the script and save it to a new script, like this one. So as you can see that because it is a very small shell, I've removed all the fancy stuff, and you have to hard code the IP address and the port number. This is the IP address of my host machine. Jenkins is running on one of the VMs in my lab. So I need to start a listener. PowerCat is what I'm going to use. It is a very useful tool. So I've started a listener on port 443. And now I believe this, let me just generate it so that we have no confusion. So let's quickly encode the one-liner to base 64 and compress it using the invoke encode utility from Nishang. This is the reverse shell we want to use. Let's just quickly copy it. Now note that we are reading it from encoded command. We can pass this encoded script to PowerShell with the -e or -encoded command parameter, and it would be executed in memory without touching disk. So let's just save this and build now. And you can see that we quickly have a connect back from 192.168.2.126, which is our slave machine, and the shell has the privileges of system. This is quite interesting and very easy to use. So that is why I recommend, if you regularly encounter Windows machines in your penetration tests, do learn PowerShell. There are a lot of tricks, tools, and techniques out there for PowerShell. Use them. They come very handy during penetration tests. So let's just exit it for right now. Sorry. Now, this was a simple use case. We can obviously, if you see the blog post, we can move on to Meterpreter as well. So there's no need to stick to PowerShell strictly. If you want to, you can move to Meterpreter as well. Now, if right now we had the ability to configure builds on slave. If we have the ability to configure builds on master, we can do even more interesting stuff. For example, we can decrypt all the credentials stored by Jenkins. So to be able to do that, first of all, Jenkins store all the SSH keys you share with it, even the private ones, in clear text, either in the credentials.xml file in the Jenkins home directory, or if you upload the key file to the Jenkins instance, to the Jenkins server, then the key file resides in the Jenkins home. So we need three pieces of information to be able to decrypt all the credentials in Jenkins. The first one is credentials.xml in Jenkins home, and then from Jenkins home/secrets directory, we need an intermediate key called hudson.util.secret and a master key file called master.key. So we can read these three. I'm using Windows instance for my demonstrations. It is exactly the same for any Linux installation as well. So we are reading these three files, credentials.xml and master.key and hudson.util.secret in byte format. So if we build it right now, this is how credentials.xml looks like. You can see that there are usernames and encrypted passwords, private keys from Jenkins home, which stay there in an encrypted format, and there are private keys in the credentials.xml itself. And then we have master.key in byte format and hudson.util.secret in byte format. Now we just need to copy these files, convert them back to the key format, and use a script. Okay, so the citation, the name of the citation slips me, but it is there in the blog. So I've credited it to the original author. The decryption script, it's a Python script, it's not my work. So we just need to pass these three things to that decryption script, and we will be able to retrieve credentials in plain. And actually, what are those credentials? Those credentials are these. Only admin user can create those credentials. So we are going to retrieve these credentials. So let's just try that out. We need to open a Kali Linux instance. And there okay, so I just read them already, and for this demonstration, I've copied them to this machine. So it is Python decrypt dot py. So we need master dot key, Hudson Newton secret, and credentials dot xml. So let's just provide those. Okay, so there was a typo, and as you can see that we were able to retrieve the passphrases and saved credentials from the Jenkins server. So once again, we were able to do that because we have the ability to build, to configure builds on master. Jenkins documentation does not recommend that, but there is no warning or anything as well if you have that. Uh, there is another interesting thing which you can do if you have access to master. That is to remove all the security on this Jenkins. That is the continuous login and log out and all those things we need to have, and that could be done by removing this file in the Jenkins home directory. So the command is just for reading that in the Jenkins uh, home. So this is Jenkins home on Windows. There is a file called config.xml. So either we can just delete the whole file and restart the service. In that case, all the security would be gone. Or if we see the console output, we read this file, we can just set this use security tag to false. In that case as well, all the security will be removed. So again, this thing is very bad. But just by assuming that if someone has access to a master, it's game over. By that mentality, we, those who built Jenkins have allowed us to remove all the security by removing just a single file or by editing a single file. Remember, in both the cases, we need to restart Jenkins. So it depends on the configuration you are targeting. On Windows machines, it is quite easy. You can just, so for example, in my tests, I was unable to do it from here. So even if I wrote, for example, PowerShell C restart service Jenkins server, I was unable to restart the service. Even from a PowerShell reverse shell like this, I was unable to restart a service. But from a Meterpreter, I was able to do that. So it could be my own instance or some problem with that. On Linux machines, Jenkins service may or may not be restarted without the root privileges. So your mileage may vary for this. So these three are the major things I want you to have a look at. But actually, even these three things are enough to lend you access to so many machines in an environment and access to things like database credentials in the log outputs or source links to private repositories and whatnot. One last thing I would like to mention here quickly is the Java unserialization vulnerability. Jenkins patched it on 11th of November, but it may take a long time to percolate this, to that patch to be percolated to productions. So maybe even a couple of years, being optimistic, couple of years actually. So let's just quickly have a look at it. To use Java unserialization vulnerability against a Jenkins instance, you must be able to connect to it on a random high port on which its CLI listens. So a public instance may not be vulnerable. I mean, if someone allows connections from the internet on higher ports, that environment is already in a bad condition. To use the Java unserialized exploit, we need a YSO serial from its GitHub repository. All these links are there in the blog post. So I'll just quickly use this payload, which is the same reverse shell we used here. So let's just start a listener. And here, let me just copy this thing. So we have the payload in the payload.out directory. And now I just need to target a Jenkins instance. This exploit you can find from the GitHub of guys at Foxglove Security. So let's just let's just run this. See that we made a connection to a random high port, and we have a connect back here. Notice that here it was from the slave, and here we are able to get it on master. In anyways, if we have access to a project, if we can configure builds on a project where we can where the executor is master, then we can achieve the same result. So this is actually pretty neat. And in internal penetration tests, this should be one of the first few things you should go for. So quite amazing. And make sure that if you want to use the Google Docs from the blog posts, use them at your own risk. And if you try to do that, just you will be amazed by the type of information available with Jenkins instances. So I believe that is all for this video, and see you at day 2 of this week of continuous intrusion tools. Have a good day.